right, now we've got an object moving meters per second, or meters in terms of time being seconds. Find the average acceleration from 0 to 3. So first I'm going to start by taking the second derivative. Well, to do that I'm going to start by taking the first derivative. All right, 3t squared minus 6t. Now I can take my second derivative, 6t minus 6. So acceleration at 0 is negative 6. So this means that I'm slowing down. It doesn't mean that necessarily that I am going in the, so if we're thinking in our fixed point as left to right, this doesn't necessarily mean that I'm going left, just that I'm slowing down. After 3 seconds, I have 12, so now I'm speeding up again. So if I wanted to find my average acceleration between those 2 points, so I'm going to say acceleration average is going to be 12 minus negative 6 over, that's a space of 3 seconds. So that's going to give me 6. So my units for acceleration, this is how my speed is changing with regards to time. So I've got kilometers per second, not t squared, second squared. Because kilometers per second is my speed, and then I look at that, how that's changing with regards to the time. Instantaneous acceleration, well, that's going to give me my second derivative at 1, which is going to be 0. So what this means is that at that moment, at 1 second, my speed is not changing. So my speed is constant at that 1 second. Let's go ahead and do the next example as well. So we're moving horizontally to fixed point O, meters, time in seconds. Find S1, V1, A1. So let's go ahead and find S1. That's O. Right, so some of you who have already done this, you've done it with a plus or a minus. I'm going to go ahead and make this plus. So S of 1 is 1 plus 6 minus 30. That's going to be negative 24. So I'm 24 meters to the left of O. So that's object, or answer B. My first derivative at 1, well, first let's find the first derivative. That's going to be 3t squared plus 12t minus 30. My second derivative is going to be 6t plus 12. So notice, as long as time is positive, my second derivative is always going to be positive, which will mean that I'm constantly accelerating. Let's go ahead and find my velocity at 1. So my speed at 1 second is going to be 3 plus 12 is 15 minus 30. That's negative 15 meters per second. So I'm moving to the, I'm continuing on to the left, 15 meters every second. My acceleration at 1 is going to be 18 meters per second squared. That means that I'm moving more and more quickly away from this point. So it doesn't mean I'm going in the positive direction. I'm not going to the right. I'm going more quickly away from, to the left of point O. So I feel like I've just answered all of these questions, and so here is our answer to B. Our answer to C, in which direction are we going? We're going to the left. We know that because our velocity at 1 second was negative. It's moving away from point O, so we're continuing to the left. So we're getting further away from it. And speeding up. Because our acceleration is positive. so we're getting faster. So going to the left because our velocity was negative, moving away because we were already to the left, which we knew from part A. So we're moving away because we were already to the left of O, and we knew that because at position 1 we had a negative value.